Okay, so my presentation is going to be in English. So first of all, so my name is Tobias Maller, and I'm affiliated with the EAD, and I'm working on the improvement of and the calibration of sulfur proxies utilizing sulfur calcium ratios and sulfur isotopes within the calcite of large benthic foraminifera. And my supervisors are Delphine Dissart from the EAD, then Cyril Marchand and Maximilien Mathian from the UNC, and Thierry Geoffrey from the IFREMER. First of all, I want to explain what foraminifera are, because probably every one of you knows them and have seen them, but probably doesn't really know what they are. They are unicellular microorganisms which are forming a calcitic shell, and they are present in every marine environment throughout the whole world at every latitude. And they are present in our oceans continuously since the Cambrian, since 540 million years. And we can use them as ecological proxies, for example, to as bioindicators in biomonitoring studies, because specific species are distinct for certain environments. And we can also use them to reconstruct past environments with the foraminiferal fauna. In my thesis in case, I'm using them as geochemical proxies, because in their calcite they are saving the informations of the seawater, and we can analyze the elements and use them as proxies to reconstruct environmental parameters such as the temperature, the pH values, or even metal concentrations in the seawater. In my thesis, I'm mainly focusing on Marginopora, which is a tropical large benthic foram, which is very common around New Caledonia and is mostly living attached on seagrass. The typical size of a small benthic foraminifera is 150 micrometers, but these large benthic foraminifera can have a size of up to 3 to 4 centimeters. In the middle, here's a picture of one of these specimens. This one is from the northern mangrove of Vauvert, and normally they are whitish, but this one is stained in rose bangle, which indicates that at the time of sampling it was alive. So what is the objective of my thesis, and why am I particularly interested in sulfur? The sulfur cycle and the carbon cycles have changed over the geological time and caused changes in the atmosphere, in the ocean, and in the climate. And it is therefore very important to unravel these processes which are driving these cycles, and to understand the consequences on the climate and also on the marine ecosystems. And this is also important because of the ongoing ocean acidification. And also, as sulfate is the second most abundant anion in the present seawater. So my aim, my target is to use the sulfur calcium ratios and to transfer them to reconstruct the sulfate concentrations in the seawater and also the past seawater sulfate concentrations. The main aspect of my thesis are culture experiments with living foraminifera, and therefore I'm sampling living samples and sediment samples around New Caledonia. And there I'm especially interested in mangroves, as mangroves are naturally releasing hydrogen sulfide and are therefore contributing to the sulfur cycle. And so far I have sampled the mangroves of Bouraké and Ouvert, and I sampled the beach of Poé, which is acting for us as a control station. For my cultures, I use the mesocosm, which is a system, a tank, where we can control different environmental parameters within a closed environment. And we set a fixed temperature for our cultures at 25 degrees, and we set fixed pH values of 7.1 and 8.1. And then we have two culture sets. We are doing the cultures with the pH without sulfur added, and then we extra add sulfur in another culture set. Then the forams, they are growing in these culture media for 4 to 5 weeks. And afterwards, the first thing we're doing is we're checking if they even grew. And we are doing this by adding a fluorescence marker, which is called calcine. This simply allows us to see which part of the foram has exactly grown in the culture, because this is the only part for my analysis I'm interested in. And so far, I did geochemical analysis at the EAD here in Noumea, and also at the NIOS, an institute in the Netherlands. And I did ICP OES measurements, laser ablation measurements, then also mass spectrometry analysis and elemental analysis. And here I can show you the first results from the laser ablation I did in the Netherlands. And I plotted various element calcium ratios versus the magnesium calcium ratio. And these are the results from the cultured marginopora. And I plotted in pink or in purple the control condition with a pH of 8.1. Then in gray, the condition which is more acidic. And then in yellow, it's the condition with the pH of 8.1 where we added sulfur. And we can see that for the top three graphs for the elements of strontium, barium, and sodium, that adding sulfur to the culture media doesn't have a significant impact on the incorporation of these elements. On the other hand, when we look at the bottom three elements, we see that adding sulfur to the culture media has more of an impact in the incorporation of these elements. For example, for nickel and for manganese, you can see that when we are adding sulfate or sulfur to the culture media, we see that the incorporation of these elements is increased. Boron in case is known to be in foraminiferal calcite to be a proxy for the acidity. And this is exactly what our data is showing. The higher the acidity, the lower the boron incorporation in these forams is. I can also show you some ICP OES measurements I did at the EAD, but this is with marginopora which were not in the culture. They were just in the aquarium. And on the left side, I plotted the sulfur-calcium ratios versus the magnesium-calcium ratio, and I plotted my values, which are these ones, versus some literature values. Here I have to say that we shouldn't focus that much on the left side because these are from low magnesium calcite, which is a completely different type of calcite my forams precipitate because they are precipitating high magnesium calcite. And the values for the sulfur calcium concentration are comparable to other ones. On the right side, I plotted some strontium calcium values versus magnesium calcium ratio. And here we reach values between 1.5 and 2 millimole per mole. And these are exactly the same values I measured before, or I showed you before with the laser ablation. So regardless of the machine and the method we're using, or in different countries, we are getting the same values, which is validating my methods. So yeah, this is a little summary. So the incorporation of strontium, barium, and sodium remains stable when we add sulfur to the culture media. Then the strontium shows the same values regardless of the machine we're using. The incorporation of nickel and manganese is increased when we add sulfur to the culture media. And the less the pH, the less the boron is incorporated into the calcite of the foraminifera. So still in progress is the data treatment from the Netherlands. And then I will have the first ever geochemical results of forams from Uvea and also from Boracay. And also my water analysis are still ongoing, and also my cultures from Uvea. And then I will write, when I gathered all the data, I will write my first paper on New Caledonian large benthic forams and the sulfur calcium signatures as sulfate seawater proxies. And my perspective for next year is I will be a few months in Japan, and I will also do culture experiments there with the same genus, with marginopora, but this time from colder water. And I will also attend a conference there and hopefully give a talk. Yeah, thank you very much. I want to thank everyone who accompanies me during my PhD, my supervisors, the EAD, the university, the IFROMER, and also the doctoral school. Thank you very much.
Merci bien. Donc, comme vous pouvez le mesurer, la recherche, elle est internationale, hein, et dans le monde, généralement, elle s'exprime en anglais. D'accord, c'est très rare qu'elle puisse s'exprimer en français. Donc, voilà, Tobias, en plus, le sujet est un peu technique. Donc, on va laisser la parole aux sachants qui veulent donc poser quelques questions. Voilà, donc le jury.
Merci pour la présentation. J'ai deux petites questions par rapport à la température. Tu as parlé de température tout à l'heure. Tu as fixé à 25 degrés. Donc ma première question, c'est pourquoi 25 degrés? Et ma deuxième question, puisque tu travailles sur des proxys, est-ce que tu envisages le proxy de l'isotope de l'oxygène, qui est un proxy très courant pour les reconstructions des températures?
Sorry, but I didn't understand the last part. Désolé.
Okay. In French, but slowly?
Better in English. I kind of got it.
Okay, I will try. So you speak about temperature. So why 25 degree?
Yes.
And the first question. And the second one is, why didn't you use of oxygen stable isotope for paleoclimatic reconstructions?
That's a good question. So the water temperature, because it's kind of the water temperature here, and in the summer it's the temperature here, so we just use it. And for the for the oxygen, it's not really planned, and we also have problems with the sulfur and the oxygen, because when we want to measure it, we have interferences, and this is kind of a problem. So we're excluding them, but it's not planned.
Yes. Okay. So I come from social sciences, so I'm not fully aware of everything you're presenting. But I'm an archaeologist, so my interest is in paleo stuff. Anything that tells us anything about past climate or past environments is of interest to me. And therefore, what is the kind of range of paleoclimatic information that you think will be available once your PhD is over? Is it something that, is it variations that we can monitor for like over 100 years or over 5,000 years or over 10,000 years or over 1 million years?
So far so our goal are 65 million years with the Paleo-Eocene terminal maximum. There's a border where we had like almost the same CO2 concentrations as today, and this is our goal therefore.
All right, okay, thank you.
Okay, thank you for your presentation, Tobias. A very simple question. I didn't get why you're measuring the effect of sulfur on the incorporation of all the other elements. So sulfur or sulfuric acid is also a very strong it also has a strong effect on the ocean acidification, and this affects every organism in the ocean, and that's actually also why we're doing that, because it has a direct effect on the ecosystem. And it represents like effect of climate change, or yes. Okay, so the more the ocean is getting warmer, but there's sulfur. I mean, it's well, we are looking at the ocean, so it's getting more acidic. That's what we are, and it's then hard for calcitic organisms to precipitate the shells, also like bivalves and so on. Okay, thank you.
Thank you. I'm just wondering, is there a link between a volcanic activity and sulfur incorporation in foraminifera? And are you going to have a look? Well, that's what we want to find out. We also have samples from Tonga, planktonic samples from Tonga, and this would be the main case to find out if there's a link or not. But we don't know yet. Thank you.